Alrighty, so today we're going to continue solving linear systems, but what you'll notice, you'll see three equations, typically because there are three unknowns, an x, a y, and a z to solve for. So you might remember this from Common Core Algebra 2, so I'll start off the same way that you were taught it back in the day in Common Core Algebra 2. So let's look at example number 1 together. They tell us x equals 3, 5x plus 4y equals negative 9, negative x plus 4y minus 2z equals negative 25. Typically, when I solve problems like this, if I'm going to use the old-fashioned algebraic method, I actually number the lines. So line 1, line 2, line 3, numerical order. And then I try to write down my plan of action. So the first step, I think makes logical sense, is to take line 1 and substitute it in line 2. So I know x already equals 3, so that's my first coordinate, right? And we're going to find a 3 variable point here. So plug in 3 for x into the second equation, and you'll see you'll have only one variable to solve for. Why? So when I solve, I get 15 plus 4y equals negative 9, good old-fashioned linear equation, subtracting 15 from both sides. 4y equals negative 24, and dividing both sides by 4, you get y equals negative 6. So now I know x is 3, I know y equals negative 6. But then I need to decide what to do next. So for me, I only have one equation to choose, line 3, because line 3 has the z variable for me to solve. So now what I would do to solve for z, I substitute in the x as 3. So we do have a negative sign here in front. So since x is 3, we'll have negative 3 to start off the equation. Plus 4 times y, we already solved for y, is negative 6. So we'll have 4 times negative 6 minus 2z equals negative 25. So now we solve for z, and we'll get negative 27 minus 2z equals negative 25. And you solve the equation to finally get the answer that z was equal to negative 1. You might recall we did something like this last year with vectors. So without taking the exam, we're kind of off the hook, but this is something very similar to that effect, if you recall. Another example I thought we'd take a look at today is example number 3 from the same worksheet. We have here x plus y minus z equals 4 is line 1. The middle line is the equation y equals 2x. That's a nice equation to work with. Slope of 2, y-intercept at the origin, 0, 0. And the third line, 3x plus y minus 4z. So after I number my lines, my first step is I'm thinking, let's replace into the first line, line 1, and the third line, line 3, with the y equals 2x. So at this point, you should have two variables. So if I do make the substitution, so there's no longer a y here, here, I have now instead, line 1 becomes x plus 2x minus z equals 4. And in line 3, x, see not y, x plus 2x minus 4z equals negative 5. So at this point, you'll have only two variables, right? So what I would do, I would combine like terms. So I'll have 3x minus z equals 4 is my first line now. 5x minus 4z equals negative 5. Now, you have two unknowns here. So what you can do, and I'm not sure if you realize it, the x's line up nicely, the z's, the equal sign, the number. So this goes back to day 2 materials. So what I would suggest doing, one of other things, I guess, is why don't you multiply the top equation by 4, then subtract the two equations to get x alone. Now, some of you might say, oh, I didn't think to do that. I thought to multiply the top equation by negative 4. So it changes the coefficients. It makes this a positive, so you can add. That works too. Some of you might say, well, I decided to multiply the top equation by 5 and the bottom equation by 3 and then subtract. That works too. Some people might multiply the top equation by negative 5 and the bottom equation all by 3 and then add. So you have your choices when you use the elimination method. So my plan, of course, I decided to multiply the top equation by 4 to create 12x minus 4 is equals 16, and then I chose to subtract. So remember here, the negative minus a negative, the signs change, so no z's. So 7x equals 21, dividing both sides by 7, I discover x is 3. Now I know x equals 3. I mean, what your plan of attack next, it's up to you, but I figure, wow, let me go back to line 2. If I know line 2 is the simple equation of y equals 2x, substitute in 3 for x, you get y is 6. And then I have to go back to find z. You could go back to the original equations because you have x and you have now y. It's up to you, or you can go back a couple steps before. If you go back to the 3x minus z equals 4, or the 5x minus 4 is equals -5, that's fine too. You have those options open as well. So go back and plug in 3 and solve for z to get 5. So you'll discover the path to start off is kind of narrow, but once you start getting a variable or two, the choices you have really opens up, and you'll have more than one perfectly fine method to solve for x, y, as well as z. We'll spend another day on this because there are some challenging ones, but I want to give you a couple to try now after watching the video. Thanks.